Solve another Leetcode problem 519 random flip matrix. So let me first explain what is the problem, because a lot of people don't understand what is the problem. Yeah. So actually we are giving a matrix, something it's gonna be like that, and then we're gonna find some index or coordinate position of x, y. So for example, if we find this position, we're gonna use a flip to, if we gonna call the flip, so we're gonna set it as 1. At some other position, so we can set it 1. And then we can use a reset. So after reset, everything gonna be 0. Yeah, everything gonna be 0. And because from beginning, everything gonna be 0. If we use a flip, it's gonna be 1. And after reset, everything gonna become 0. Yeah. So this is the idea, but we need to know that we need to design an algorithm to randomly pick an index. This means for the index, we need to pick it randomly. Yeah. So in Python, we can use a randint for this problem. Yeah. Now let's just try to solve it. So I'm gonna use the self.r equal to n plus 1, because I'm gonna choose some integers from 0 to n minus 1. And self.c gonna equal to n minus 1, and I also need to prepare a set. Because if I flip one position, so for example, this is 1, so for the next, I cannot flip this again. I have to flip 0 to 1 instead of 1 to 0, so this is why I need to use a weighted set. So this is my weighted set, and now, what about the reset? Yeah. So for the reset, I just need to clear the weighted set. I'm gonna call a clear. And what about the flip? So for the flip, I'm gonna prepare two values. It's gonna be x, y. It's gonna be the coordinate position inside the matrix. Yeah, because for this problem, we cannot define a matrix and then we're gonna try to flip some points, because it's going to be time limit exceeded, because there's going to be 1000 calls for the flip and reset. That is why we cannot prepare a matrix like m times n matrix, because this is 10 to the power of 4, it's going to be 10 to the power of 8. Definitely it will not work. Yeah. So this is why we're going to find xy from the randint. So the random integer from 0 to self.r. And similarly for y, we're gonna try to find a random integer from 0 to self.c. Yeah. So finally, I'm gonna return this xy, because the final return is gonna be a list of integer. It's gonna be this x and y. Yeah. But I need to put it inside a weighted set. If it is not inside it, I'm gonna have a return. So if this x, y not inside the weighted set, it means I can set it. Yeah, I can flip it. Yeah, so I'm gonna put it inside the weighted set, and I can directly return. Yeah, but before that, I need to use a while loop to set it to true, and then I can try the xy coordinates. Yeah, so if I didn't find it, I'm gonna continue to find it until I find xy position, which is not inside the weighted set, and I can directly have a return. Yeah. Now let me just run it. So it's gonna be the self.weighted set. Yeah. Now as you can see, it works. Now let me just submit it to check if it can pass. Yeah, as you can see, it passed for all testing cases, and it's pretty fast. So for the time complexity, normally we don't need to analyze the reset and the init, but what about the flip? Yeah, so for this flip, we are setting a true, and we are randomly introduce some numbers. Maybe in between, it's gonna have a clear of the weighted set. It is okay for us, but what happens, it's gonna collect a lot of points inside the weighted set, and the next one maybe it's a duplicate, and we didn't find something new. So yeah, so for this one, it's really difficult to analyze the time complexity, because we are using the random. We are not sure at which time it's gonna introduce a new new coordinates inside the set. We are not sure. But for average, so for example, for average maybe 1000 courses is enough. Yeah, maybe 10,000, but we are not sure because this is a random algorithm. It's really difficult to analyze the time complexity. Yeah, so for example, if this is a really big mn, yeah, if this mn is really big, so for the random maybe there's no duplicate inside the weighted set, but we don't know how many times for this while true. Maybe after 1000 times it is enough for us to find something new. Yeah. So for this problem, I don't want to analyze the time complexity, but we can solve it by using the weighted set. Thank you for watching. See you next time.